Hello, my dear students. Myself, Dr. Lakshma HR, working as an assistant professor, Department of Commerce and Management, Government First Aid College, Anekal, Bangalore district. In the previous session, we solved the problems on rank correlation. And this is the chapter of correlation and regression analysis. So so far we are already completed the correlation coefficient of correlation. That is, in that we have solved the problems on the Spearman's rank correlation, that when the ranks are given and when the ranks are similar and when the ranks are not given, we solve the problems. In today's session, let us solve the problems on regression analysis. So before we going to start the problems on regression analysis, let us study what do you mean by regression analysis, meaning and definition of regression analysis. So meaning, regression is a measure of average relationship between two or more variables in terms of the original units of the data. So like a correlation, regression is also a measure of relationship between two or more variables. So in simple, it is the prediction of the value of dependent variables on the basis of independent variables. If you want to predict, if you want to find out the value, then we are going to use the technique or the method of regression analysis. Okay. So definition of regression analysis is, according to Richmond, it is the technique for the derivation of an equation by which one of variable, the dependent variable may be estimate. Estimate is nothing but prediction. So estimate by other variable, the independent variable. So with the one variable, we have to find out the value of another variable through the technique of regression analysis. Okay, students. Now, let us move on to the formulas for the regression coefficient of correlation. Regression equation through regression coefficient. There are two regression lines is there. That is regression equation x on y and y on x. There are two regression equation lines. First one is x on y and y on x. So for x on y, the formula is x minus x mean is equal to sigma xy divided by sigma y square y minus y mean. Okay, this is the formula for calculating x on y. Okay, if in the problem, if they're not given the two variables, instead of two variables, if they give directly in the problem, the correlation as well as standard deviation of x and standard deviation of y, as well as x mean and y mean, we have to use this formula. That is, x minus x mean is equal to correlation standard deviation x divided by standard deviation y, y minus y mean. Okay, if in the problem, if two variables are given in the problem, then we have to put this formula for calculating regression equation x on y. If they are not given the two variables, if they directly given the data like this correlation this much and standard deviation x and standard deviation y this much and x mean and y mean, if they give the values like that, we are apply this formula. Okay, this is first regression equation x on y. X on y, this is the formula. So now y on x is regression equation y on x. For this y on x, the formula is y minus y mean is equal to sigma xy divided by sigma x square x minus x mean. So this formula we are going to use for the y on x equation. Okay. Or this is, if they're given in the problem correlation, standard deviation and mean, x mean as well as y mean, we are going to apply this formula. So that is y minus y mean is equal to correlation into standard deviation y divided by standard deviation x, x minus x mean. So this is the formula we are going to use when they are given in the problem correlation, standard deviation, as well as x mean and y mean. Okay. Now let us solve the problems on this method. So this is the problem. Calculate the two regression equation from the following data. See, the data they are given like this. Okay. This is x mean is equal to 20, y mean is equal to 12, standard deviation of x is equal to 5, standard deviation of y is equal to 25, and r is equal to 0.80. So if they are given the data like this, which formula we are going to use? We are going to use the second formula. See, this is second formula we are going to use because they are given x mean value, y mean value, correlation, standard deviation y value they are given, standard deviation x value they are given. So we are going to apply this formula for calculating regression equation x on y as well as y on x. Okay. So this is regression equation y on x. Okay. So for this formula is like this: y minus y mean is equal to r into standard deviation y divided by standard deviation x, x minus x mean. Okay, this is the formula for calculating regression equation y on x. So y minus y mean is how much? Here 12 is there. So 12 is equal to the correlation is 0.80. So 0.80 into the standard deviation y is how much? 25. 25 divided by standard deviation x is 5 divided by 5 into x as it is minus x mean is how much? 20. X mean is equal to 20. Okay. We have to put the values like this. Now y minus 12 is equal to 0.8 into 25 divided by 5. If you will make, you will get 4. 0.8 into 25 divided by 5. Okay, students, you will get 4. So take as it is x minus 20. Next step is y minus 12 is equal to 4 into x, 4x, minus 4 into 20, 80. Okay. Now y is equal to 4x minus 80 minus, if you will put like this, you will get plus 12. So minus 12, it will become plus 12. Okay. Now y is equal to 4x as it is. See here, minus into plus, it will be minus. So we have to put minus sign. Minus 80 minus 12 is equal to 68. So this is regression equation 1, that is y on x is equal to y is equal to 4x minus 68. This is regression equation 1. Okay, students. Next, we move on to regression equation x on y. So this is x on y. For this, the formula is x minus x mean is equal to a correlation, standard deviation x divided by standard deviation y, y minus y mean. So x minus x mean 20 given in the problem, 0.8 is rank correlation given in the problem, standard deviation x 5 and standard deviation y 25, y minus y mean given in the problem 12. Okay. Now we have to make the substitute this formula. X minus 20 is equal to 0.8 into 5 divided by 25. You will get 0.16. Okay, students, here 0.8 into 5 divided by 25. You will get 0.16 into y minus 12. Okay. Now x minus 20 is equal to 0.16y into y 0.16y minus 0.16 into 12 into 12, 1.92. So x is equal to 0.16y minus 1.92 minus 20. If we will bring this side, it will become plus 20. Now what we have to do? X is equal to 0.16y plus, see here, minus into plus, it will become minus, but here plus 20 value is more. Therefore, you write plus 18.08. This is regression equation 2, that is x on y. Okay, students. So previously you got equation y on x, you got y is equal to 4x minus 68. Okay, here x on y, you got here x is equal to 0.16y plus 18.08. Okay, students. Like this, we have to compute two regression equations, y on x as well as x on y. Okay. Now let us move on to the next problem. The correlation coefficient between the variables x and y is 0.60. So this is coefficient, correlation coefficient is 0.60. If x mean is equal to 10, y mean is equal to 20, standard deviation x is equal to 1.50, standard deviation y is equal to 2, calculate two regression equation. Okay, if they are given the values like that, which formula we are going to use? We are going to use this formula, that is second formula. So they are given correlation here, correlation 0.60 given in the problem, x mean given, y mean also given, standard deviation x given, and standard deviation y also given in the problem. So if they give the data like this, we are going to apply this formula. So first regression equation y on x. For this, y minus y mean is equal to correlation into standard deviation y divided by standard deviation x, x minus x mean. So y minus y mean is 20. So take 20 is equal to correlation is 0.60 into the standard deviation y is should be 2. 2 divided by 1.5 into x minus x mean is 10. 10 take as it is. So y minus 20 is equal to 0.8, that is 0.60 multiplied to 2 divided by 1.5. Okay, students, here 0.60 into 2 divided by 1.5. How much you will get? 0.8. Okay, into x minus 10. So y minus 20 is equal to 0.8 into x. It will become 0.8x minus 0.8 into 10. You will get minus 8. Okay. So next step is y is equal to, bring x this side. So 0.8xx minus 8 minus 20. If you will bring this side, it will become plus 20. So this is the step. See here, y is equal to 0.8x plus 12. See here, 0.8x minus into plus, it will become minus. But here plus 20 is more. The value of plus 20 is more. Therefore, you have to take plus 12. So y is equal to 0.8x plus 12. This is regression equation y on x. Okay, students. Next, move on to the next equation, that is x on y. This is regression equation x on y. For calculating x on y, we are apply this formula, that is x minus x mean is equal to correlation into standard deviation x divided by standard deviation y, y minus y mean. So x minus x mean, they are given in the problem itself 10. That is equal to 0.60 correlation value given, 1.5 is standard deviation x, you take as it is. 2 is standard deviation y, you take as it is. Y minus y min is 20. So next step is x minus 10 is equal to 0.60 into 1.5 divided by 2. If you will do like that, you will get 0.45. Okay, students, see here 0.60 into 1.5 divided by 2. You will get 0.45 into y minus 20. Next is x minus 10 is equal to 0.45y into y. It will become 0.45y. Okay, minus 0.45 into 20. If you will multiply with 20, you will get 9. Okay, so now x is equal to 0.45y minus 9 plus 10. Okay, so now x is equal to 0.45y. See here, minus into plus, it will become minus, but plus 10, the value is more. Therefore, put plus 1. Okay, so see here, x is equal to 0.45y plus 1. This is regression equation 2, that is x on y equation. So in the regression equation, you have two regression equations. One is y on x and another one is x on y. So if they are given the data like that, you have to apply the formula like this. This formula you are going to use for calculating the regression equation, x on y as well as y on x. So this is second equation we got here, and this is first equation we got here. Okay, so practice this type of problems. So we continue on the next class. Okay, students, we continue in the next class. Thank you.